Hello, today we're going to talk about sleep. Sleep is a very fascinating topic to consider, especially when we appreciate that we spend about a third of our lives sleeping. We operate according to a biological clock, and that biological clock resets about every 24 hours. That biological clock regulates our sleep and our waking time according to what's called a circadian rhythm. Circa meaning around and dia a day. We have other kinds of biological clocks that work in our lives, like say a woman's menstrual cycle that revolves around a 28-day time period. But as we all know, sleep revolves around about a 24-hour period. As it turns out, we have a structure in our brain near our hypothalamus called the SCN for short, or for long, the suprachiasmatic nucleus. And when this structure is exposed to light, it resets our biological clock. Pretty fascinating. One area of great interest to psychologists is the whole general area of consciousness and how our brain makes it possible for us to experience consciousness. And when we sleep, we undergo a natural loss of consciousness. During our sleep, we have both what's called rapid eye movement sleep or REM sleep, and then we have non-rapid eye movement sleep called non-REM sleep. It appears to be primarily when we are having REM sleep that we dream. And as we'll see, dreaming takes place several times throughout the night. REM sleep is also referred to as being paradoxical. When something is paradoxical, it's sort of the opposite of what you might expect happens. Because while it is the fact that we are asleep, um, our muscles become very relaxed when we are in REM sleep. In fact, we experience a kind of temporary paralysis when we are in REM sleep. You may have experienced this before if you wake up in the middle of REM sleep and it's hard for you to move your arm or your leg would be an example of that. But even though our body is inactive in that way, in another way, our body is highly active, and that has to do with the activation of our autonomic nervous system, the sympathetic part of it, because we tend to be in a state of heightened physiological arousal when we are in REM sleep. Researchers have made a lot of progress in studying sleep by using the EEG machine that we learned about a little earlier in this chapter, the electroencephalograph, which allows us to measure brain waves. When we begin to become real relaxed and drowsy before we fall off to sleep, we experience a special kind of brain wave called alpha waves that can be detected by the EEG. And then we eventually go into a state of non-REM sleep. There are 3 stages of non-REM sleep, each stage a little deeper than the one before it. And then, after we've gone through these 3 stages of non-REM sleep, we tend to come up out of those stages and go into the stage of REM sleep when we dream. In this diagram, we can see the different kinds of brain waves that occur throughout the night. As you can see, waking beta waves are low amplitude, high frequency waves, and we tend to have these waves when we're in an alert state. And as we already mentioned, alpha waves occur when we begin to feel drowsy. And alpha waves are high amplitude and high frequency waves, as you can see. Then when we go into the first stage of sleep, non-REM stage 1, our brain waves are starting to slow down a little bit. We have what are called theta waves then, and then in non-REM 2 sleep, some other changes take place. We have some sort of like little eruptions, as you can see, of brain waves there, like when they shoot up and then down. These are called K-complex and spindles that occur in a non-REM 2 sleep. And then in non-REM 3 sleep, the very deepest level of sleep, which is the most restful level of sleep for us, we have high amplitude, as you can see, low frequency waves. And then something very fascinating happens when we go into REM sleep, rapid eye movement sleep. When we dream, our brain waves look very similar to what they are like when we are alert and awake, or at least in the very first stage of sleep. As you can see, very similar, especially to N1 waves, indicating that our brain is more active in terms of its electrical activity when we are in REM sleep. It takes about 45 minutes to an hour once we fall asleep before we go into REM sleep. The duration of REM sleep varies throughout the night, tends to be shorter when we have REM intervals early in the night and longer when we have REM sleep intervals in the second half of the night or in the early morning hours, would be another way of putting it. And as we said before, there are physiological changes that occur in our body when we are having REM sleep. Increase in physiological arousal that would be manifested by increased heart rate and increased breathing. Then it's called rapid eye movement sleep because our eyes do tend to dart around underneath our eyelids when we are in REM sleep and are starting to dream. Here we can see EEG recordings of a typical young adult and an older adult, showing brainwave activity and stages of sleep throughout the night. As you can see, when you compare these two graphs, that young adults tend to enjoy really better sleep because they don't wake up nearly as much during the night as older adults typically. And they tend to have longer REM intervals and more time spent in really deep sleep. As you follow the line here, you can see that when this person falls asleep, they gradually go into deeper sleep, and then they stay in deep sleep for a while, and they come back out of it, and eventually they dream for just a little bit. You know, that looks like what, maybe 10 or 15 minutes, and then they go into deep sleep again and come back out of it. Here the person actually wakes up, then they go back to sleep, go into deep sleep, come back out of it, dream again, and wake up again, dream again, and then dream one more time. So you can see if we don't get enough sleep, we're cutting ourselves out of some really quality dream time. Let's say, for example, if this person was only able to have 5 hours sleep, then they would miss out on all of this additional REM sleep and even the somewhat deeper sleep here where they go into stage 2 sleep. As you can see, there's more, the stage 3 sleep tends to occur in the first half of the night, and the REM intervals when dreaming takes place tend to be longer in the second half of the night. Why do we sleep? Sleep protects us because when we're asleep, usually we're in a safe place and we are able to not be afraid of our surroundings so we can sleep through the night. Sleep also has a protective effect on our bodies because it gives our bodies time to relax and also to recover in physiological ways and dealing with the stresses and of the day and the depletion of neurotransmitters during the day and things like that. Sleep is very renewing. Sleep is also an important time when we restore and rebuild memories. In fact, researchers have found when we're learning new things, it's during our sleep when these new memories are formed and stored in our brains. So if we're learning academic information, being able to sleep on it and then come back to it and work on learning it further and sleep on it, come back to it, work on learning it further, helps us to learn more effectively and to have stronger memories that we can recall when we need them. Sleep also helps to stimulate creative thinking. Have you ever had an experience where maybe you were contemplating some sort of a problem in your life, or maybe something new that you were learning and you didn't quite get it yet, and you sleep on it and you wake up and voila, the answer comes to you. This has happened to me so many times in my life that I've developed a very healthy respect for how our brain is continuing to work for us when we are asleep. And of course, sleep supports growth, physical growth of the body, growth of cells within the body. Little babies spend an awful lot of time sleeping, in part because their brains are so actively growing. Of course, the rest of their body is too, but lots happening inside their little heads early in life, requiring them to sleep a lot so that these processes can take place. Think for a moment about how you are affected when you don't get enough sleep. So we don't tend to be affected in a good way when we don't get enough sleep. Here are some ways in which sleep deprivation can affect us. It can put us in a bad mood. It can make us more irritable. It can weaken our immune system and make us more susceptible to infection. It can interfere with our ability to drive safely. It can interfere with our school performance. It can contribute to weight gain. And nowadays, researchers have emphasized how many of us just don't get enough sleep. And we walk around tired a lot of the time. And some people refer to this as the great sleep recession. I can't emphasize to you strongly enough the importance of getting good, restful sleep. It helps us in so many different ways. Sometimes we experience persistent problems with sleep to where we might actually suffer from a sleep disorder. As you're probably aware, the most common sleep disorder is insomnia, where we may have difficulty falling asleep or staying asleep. Probably all of us at one time or another will have some nights when we don't sleep really well. Maybe we're under a lot of stress or worried about something. Usually that's short-lived and we get over it and we get back to sleeping more regularly again. But for some people, the problem with insomnia persists to where it may actually become necessary for them to get help for themselves. Narcolepsy, which is a rare sleep disorder, is a fascinating disorder where a person has sudden attacks of overwhelming sleepiness. They may just suddenly drop off to sleep. And of course, if that happens to them, that can be dangerous. You know, they could fall and hurt themselves, or they could have a car accident. Even animals like dogs have been found sometimes to suffer from narcolepsy. And little dogs, when they get really excited, uh, they are more likely to have this happen to them. Sleep apnea is a much more common sleep disorder than narcolepsy, and you may have someone in your family who uses in a sleep machine, in CPAP machine, in order to help them to sleep, helps them to be able to breathe better during the night, because with sleep apnea, the person's not breathing well during the night, and they tend to have many different disruptions to their sleep cycle. So they're like having these little uh, micro events when they wake up just very quickly, and then go back to sleep. They might not even be consciously aware of when it's happening to them, but it's really disrupting their sleep cycle and making it hard for them to get a full night's sleep. Sleepwalking and sleep talking also tend to occur in deeper sleep, in non-REM stage 3 sleep. Sometimes people will actually get up and go in the kitchen, fix themselves something to eat, go back to bed, and they have no recollection of doing it because they were asleep the whole time when they engage in these activities. And night terrors, which occur more often in children than adults, also tend to occur um, during non-REM 3 sleep. And here the person appears terrified. You would think they were having a scary dream, but they're not. They are just talking nonsense. Often they sit up, they may walk around, but they're still asleep in non-REM 3 sleep. When children have these experiences, it can be helpful to actually look at when they tend to occur during the night. And at least some people recommend this who have treat sleep disorders, and then to go in and wake them up before it happens, and then help them go back to sleep uh, to decrease the frequency of night terrors. But as you can see, night terrors tend to um, get better going into adulthood because they affect children more than they do adults. If a person is experiencing a sleep disorder, they may benefit from seeing a specialist who helps people with sleep disorders. And often this is actually might be a team of professionals who work together, including medical personnel and psychological professionals who work together to figure out the best way to help the patient. And the patient may undergo a sleep study where they spend the night in a sleep lab where they're hooked up to uh, machines that measure things like brain waves and respiration and muscle tension and eye movement and leg movement and things like that, and video the person sleeping throughout the night to see if they do seem to be having a sleep disorder, and if so, which type of disorder, in order to figure out how they might be helped. With regard to insomnia, sometimes people will be placed on medication for insomnia which may help them. But one of the problems with a lot of the medication that's used for insomnia is it can be habit forming. And then as the person tries to get off of the medication, they may have even more difficulty sleeping. So that's something to be aware of if one ever were in a position where they were considering taking medication. Of course, any decisions about sleep disorders and how to treat them ideally would be made in the context of a relationship with a highly trained person, professional person who specializes in sleep disorders and knows a lot about them and how to help people who experience sleep disorders. There are also a number of things that we can do in our lifestyle choices that can either help us to sleep better or interfere with our sleeping. This is a list of some of those activities. I just want to briefly go over them with you. These are things that any of us can practice and can help us to sleep better. And one of the things that I hope comes out of this discussion is that we'll all appreciate even more so the importance of a good night's rest and do what we can to help us to consistently sleep well. So regular exercise is good, but it needs to be a little earlier in the day so that we don't get our bodies all revved up right before going to sleep from doing some sort of exercise activity. It's also a good idea to avoid caffeine after the early afternoon and avoid eating and drinking near bedtime. Now, milk can sometimes help us because, as you can see, the raw materials in milk help to manufacture serotonin, which is a neurotransmitter that facilitates sleep. It's helpful to have like some quiet, relaxing time before falling asleep where we can dim down the lights. It's helpful to have a regular sleep schedule where we can go to sleep around the same time and get up around the same time, and to do that consistently, and also to avoid long naps, especially if we're having difficulty sleeping. Um, College students, because they have so much going on, oftentimes they don't get enough sleep during the week, and they may catch up on their sleep on the weekends, and there's something to be said for that. But we're just saying here that to the extent possible, it's helpful to be on a regular schedule so our body gets used to going to sleep around the same time and waking up around the same time, and that we can get enough sleep. It's helpful not to be easily able to look at what time it is, when we're sleeping. So hiding time displays so you aren't tempted to check them repeatedly. This is something that we could very easily do. I've done it many times where, especially if you get up early in the morning or you have something really special that you have to get ready for, you're afraid you might not get up in time for it. So you wake up many times during the night, checking the clock to make sure you haven't slept through it. It can be helpful for us to reassure ourselves if we're going through a brief period of time where we're not sleeping well, that, hey, this tends to be temporary, and we can look forward to getting back to a normal sleep pattern again, and to try to identify the factors that may be interfering with our sleep so we can address those if possible. It can also be helpful to ease our minds by focusing on non-arousing, engaging thoughts like song lyrics or vacation travel, or some people enjoy listening to certain kinds of music that help them to fall asleep, and to work on being able to manage stress effectively so that we can help ourselves get into a nice, relaxed state of mind and body uh, when we go to bed at night. These are just some of the sleep aids that researchers have investigated we'll just stick with these for now. But it gives us all some things to think about as we work on helping ourselves to promote healthy sleep patterns. Before we leave this topic of sleep, I'd like to talk a little bit about dreaming. Dreams are so fascinating. I find it really interesting to pay attention to my own dreams and to ponder what they may mean. People have written a lot about why we dream and are dreams significant, and if so, how might they be interpreted? But here are some ideas about why we dream. Dreaming may be a way of satisfying our own wishes in our dream life that sometimes we may not be able to satisfy in our waking life. Dreams may be a way of filing away memories that then we can recall at a later time when we need them. Dreams may be a way of developing and preserving neural pathways. Dreams may be our brain's way of making sense of neural static that occurs when we're sleeping. And dreams may also reflect cognitive development as we develop more so cognitively. Our dreams may actually change along with that. Various people have developed theories about dreaming. One is Sigmund Freud, whom we mentioned in our first chapter and whom we'll be talking about later on in our time together. If you recall, Freud emphasized that we have an unconscious mind, and he believed that dreams are a way in which our unconscious mind can become known to us. In fact, he said dreams are the royal road to the unconscious, and that dreams can be a way for us to express wishes on a dream level that we might not be able to express in our waking life. Dreams may also be associated with sort of a way that we sift through the day's events in our memory and sort some things out and process our experience. And as we mentioned before, dreams can also be a way of developing and preserving neural pathways because different kinds of life experiences that we have tend to pave new neural pathways. Think about learning, for example. When we learn new things and those experiences become memories that are stored in our brain, new pathways are created where networks of neurons make new connections with one another. Dreams may also be a way that our mind is trying to make sense of like random neural activity that goes on in our brain when we're sleeping, spreading upward from the brainstem to the cortex during sleep. And as our brain develops and becomes more mature and we become more cognitively sophisticated, this may also be reflected in how we dream. So as you can see from these different theories of dreaming, one is not better than another. These are just different ways of thinking about dreaming. If you're interested in your dreams and wanting to reflect on them and understand them better, one method you might consider is keeping a notebook by your bed. And when you awake from a dream, you might actually write down what you can remember about that dream and then come back to it later and think about your dream and reflect on it and what it might mean. There's not a right or wrong answer there. Different ways of looking at it and thinking about it. But many people enjoy the opportunity to reflect on their dreams and think about what they might mean and how they might use that information in their waking life. This completes our discussion about dreams and this section on the brain. Thank you.